What's up guys, this is Massey. Welcome to another video. In this video I want to talk about the rate of change. The rate of change is a measure of the change in one quantity, which we call it dependent variable, with respect to a change in another quantity, which we call it independent variable. There are two types of rate of change: average rate of change and instantaneous rate of change. What's the difference? The average rate of change is the change that takes place over an interval, and instantaneous rate of change is the change that takes place in an instant. So that's why this one is called AROC, and this one is called IROC. Average rate of change and instantaneous rate of change. The formula for these two are exactly the same thing, but here the change in the independent variable is very small. The average rate of change between 2 points corresponds to a slope of the secant between the points. The average rate of change of y with respect to x between 2 points p1 and p2 is determined as follows. Average rate of change is delta y divided by delta x, which is change in y divided by change in x. So y2 minus y1 divided by x2 subtract x1. So average rate of change can be determined by calculating the slope between 2 points given in the table of values or by using an equation. Let's see some examples. Let's take a look to this example. It says the price P of one share in a company at any time t in years can be modeled by this function. P of t equals to negative 0.3 t cubed plus 2.1 t squared plus 7t plus 2. And t is between 0 and 15, including these two numbers. So the independent variable here is time in terms of years, and dependent variable is price in terms of dollar. So we have 4 questions in here. It says determine the average rate of change of the price from year 0 to year 5. So what I'm gonna do, I'm gonna find out the price at time 0. So it's gonna be negative 0.3 t 0 to the power of 3 plus 2.1 0 to the power of 2 plus 7 times 0 plus 2 equals 2. P of t equals to 5 is going to be negative 0.3 5 to the power of 3 plus 2.1 5 to the power of 2 plus 7 times 5 plus 2. So that's going to be negative 0.3 times 5 squared. That's going to be 52. So the rate of change is going to be change in P divided by change in time. So it's going to be 52 subtract 2 over 5 minus 0. So it's going to be 50 over 5. So 10. It's going to be $10 per year. So it means that every year, on average, it increased by $10. That's average rate of change between 0 to 5. It doesn't mean the average rate of change from 5 to 8 be the same as 0 to 5. It's not necessarily true. So let's find out the other average rate of changes. So in order to find it, we need to find the price year 8. It's going to be 38.8. So we have delta P over delta T is going to be 38.8 subtract 52 over 8 minus 5. So that's gonna be 38.8 minus 52. That's negative 13.2 divided by 3. That's gonna be negative 440. It means that on average, from year 5 to year 18, the price went down by $4.40. So that's going to be the average rate of change on the second part. Now let's do from year 8 to 10. From year 8, we have that. We need to find out the price after 10 years. So it's going to be P, T equals to 10, negative 0.3, 10 to the power of 3, plus 2.1, 10 to the power of 2, 7 times 10, plus 2. So that's going to be negative 300 plus 210 plus 70 plus 2. That's going to be negative 18. So delta P over delta T is going to be negative 18. Subtract the price after 8. It was 38.8 over 10 minus 8. So negative 18 minus 38.8 is going to be negative 56.8 divided by 2. That's going to be negative 28.4 or negative $28.40. It means that on average every year 28.40 decrease in price per year. And the last part, we need to find out the year from 10 to 15. So we need to find out the price after 15 years first. So it's going to be negative 0.3, 15 to the power of 3, plus 2.1, 15 to the power of 2, plus 7 times 15, plus 2. So that's going to be negative 0.3 times 15 to the power of 3, plus 2.1 times 15 to the power of 2, plus 7 times 15 plus 2. That's going to be negative 433. So it is going to be negative 433 subtract negative 18 divided by 15 minus 10. So negative 433 plus 18 divided by 5 is going to be negative 83 or negative $83. So $83 down every year on average. So that's how we deal with average rate of change. Now let's take a look to the next example. It says football is kicked into the air and height h in terms of meters can be modeled with respect to time t in terms of seconds by the function h of t equals to negative 4.9 t squared plus 10t plus 1. Now we have two questions. Determine the average rate of change of the height of the ball of each time interval from 0 to 0.5 and from 1 to 1.5. Let's find out the first part first. So h of times 0 is going to be negative 4.9, 0 squared plus 10 times 0 plus 1 is going to be 1. ht 0.5 is going to be negative 4.9, 0.5 to the power of 2 plus 10, 0.5 plus 1. That's going to be negative 4.9 times 0.5 to the power of 2. It's going to be 4.775. That's going to be delta H over delta T. 4.775 minus 1 over 0.5 minus 0. That's going to be 3.775 over 0.5. 7.55 meters per second. And the second part is going to be, we need to find out the height at 1.5 and also at 1. That's gonna be 4.975 meters, and when time is 1, it's gonna be negative 4.9 plus 10 plus 1. That's gonna be 6.1 meters. Delta H over delta T will be 4.975 minus 6.1. It's gonna be 1.5 minus 1. Going to be negative 2.25 meters per second. So obviously when you compare these two average rate of change, so this one is positive, it means that the height is gonna go up with respect to time because it's going up, and the other time is falling, which means that the average rate of change is negative, which means that the height is going down with respect to time. So that's how we can analyze the value we have for average rate of change. Let's take a look to this example to find out how to calculate instantaneous rate of change, which, as I said earlier, you're going to use the same formula. But whenever you are dealing with instantaneous rate of change, in the beginning you have only one time. So for example, in this case, it says a football is kicked into the air and height h in terms of meters can be modeled with respect to time, t in terms of seconds. By the function this, estimate the instantaneous rate of change of height with respect to time at t equals to 1 second, for example. So we have only 1 point right now. Let's take a look and find out the height at time 1. So it's going to be 4.91 squared plus 21 plus 3. That will be 29 minus 4.9. It's going to be 24.1 meters. So when time is 1, height is 24.1. Now imagine if time is 1.1. We just change the independent variable to something just a little bit bigger than 1. 1.1 or 1.2 or 1.5 or 1.01. So whenever you make it smaller, it's gonna be more accurate. So t equals to, in height of t when t is 1.1 is going to be negative 4.9, 1.1 to the power of 2 plus 20 times 1.1 plus 3. So now let's take a look and find out negative 4.9 times 1.1 to the power of 2 plus 20 times 1.1 plus 3. So that's going to be 19.071. So then you can say delta H over delta T is going to be 19.071. Subtract 24.1 over 1.1 minus 1. So that's 19.071 minus 24.1. It's just gonna be 23. So here it was 18.1, not 24.18.1. So it's gonna be 19.071. Subtract 18.1. I just realized that I need to double check that number, which was far from the other number. So 0.971 divided by 1.1 minus 1 is going to be 0.1. When you divide it, it's going to be 9.71. It means that meter per second, kind of like speed, it's going to be 9.71 meters per second. That's the change of height with respect to time, and we basically calculated the instantaneous rate of change. For instantaneous rate of change, as I said, you can change 1 to something like 1.1 or 1.01 or 1.05, 1.2. So you need to make it something very, very small. So that's the definition of average rate of change and instantaneous rate of change. I hope you enjoyed this video. Please leave me a comment if you have any question, and please don't forget to subscribe this channel. You can find out lots of videos regarding math, physics, and chemistry. Thank you for watching and have a great day.